Hey guys, hi everyone. Well, my name is Ayush, and I am a staff software engineer at Turo, and today I'll be speaking about how we adopted and integrated Temporal. Well, a lot of you might be asking, what is Turo? We're the world's largest car sharing marketplace where you can book any car you want, wherever you want, and whenever you want it. We have a vibrant community of guests and hosts who use our platform for a variety of car sharing related experiences. Our mission is to put the world's 1.5 billion cars to better use. Our amazing hosts are the reason for the variety of vehicles that we have on our platform. Turo hosts can be found in more than 11,000 cities across the US, UK, Canada, Australia, and France, where they have earned more than $2.7 billion since inception. An equally essential part of our community are our guests. Turo currently has more than 3.1 million active guests who have used their bookings at Turo to drive more than 4.7 billion miles. We also have a net promoter score of 80. I'm not too sure what that means. I got these slides from our marketing team. Turo has been around for some years, and we've experienced incredible growth. In 2013, we reached a milestone of $1 million in net revenue in a single year. By 2020, we had managed to reach $1 million in net revenue in a single day. To put our scale into numbers, we see more than 7 million unique visitors per week, 700 million plus HTTP requests per week, 175,000 iOS app installs per week, 25 billion plus database operations per week, 2 billion plus search sessions per week, and more than 2 million images uploaded per week, all while maintaining 99.9% uptime. Considering these growing numbers, it is imperative that the software that we use scales. This need to scale led to the formation of my team, API Services. Our team was formed a little more than a year ago. We are part of Turo's core services domain. The goal of the team is to focus on improving scale at Turo through monolith decomposition, event-driven design, and driving adoption of new scalable platforms. Well, now that you know about Turo, what we're trying to build, and what we stand for, you must be wondering what brought us here at Temporal Replay. Well, it's a challenge that we've been facing throughout our growth, scaling our delayed job platform. Before we adopted workflows, we used Quartz, an open source scheduling library that integrated pretty well with our Java application. Since we're a big Java shop here at Turo, it was a natural choice for our scheduling system. It worked well for us for several years until it didn't. Quartz has not been able to keep up with Turo's growth. We consistently saw misfires, which were jobs that don't fire at the expected time, and stuck jobs, which are misfired or regular jobs which were stuck in an error state and had ceased to fire. And oftentimes we would also observe that Quartz would get stuck in this thing we like to call a death loop, where misfired jobs we prioritize for firing above regular jobs, which will lead to more misfired jobs, so on and so forth, causing a vicious cycle. Also, Quartz was easy to misuse and had been misused. Many tasks were often bound to a single pod, which, as we all know, doesn't scale. There was a lack of priority and distinction between critical and non-critical jobs. And oftentimes, Quartz was also used to run expensive workloads, which ran for hours at a time. And there was no easy way to decouple scheduling from execution. Tasked with this challenge, the first thing that our team focused on was improving Quartz's performance. Our initial attempt to do so was to decouple Quartz job firing from execution. This is just another way of saying we introduced queues everywhere. Some of the other things that we did was we tried to add fine-grained control over our workers, added some more fine-tuning to the retries that Quartz already did. We tried to add some new rate-limiting features onto Quartz, added some form of job prioritization, and also just threw more pods at it, try to horizontally scale things. All of these changes led to marginal improvements, which, much like the fictional Homer car, introduced even more complexity into an already complex system. Faced with this, we decided that maybe it was time to take a step back and look for a platform that would better fit our needs and better prepare us for the future. we started to brainstorm about things we would like to see in this new platform. The criteria we decided was based on things that we liked about Quartz and things that have been huge pain points for us in the past. Our criteria included high scalability, fault tolerance, obviously cost, something that was fully managed since we were managing our own instance of Quartz before and had been severely scarred doing so. Something that had some form of concurrency control. This is something Quartz did not have. Something that allowed us some editing or signaling capability. This is something that Quartz did provide us with and we liked since our reservations and bookings can oftentimes be edited. Something that provided us with a positive developer experience. The last one is a little selfish. With our evaluation criteria set, we started looking externally and found quite a few platforms that seemed like they would be good fit for our needs. Some of the platforms that we zeroed in on was Dine-In, which is Airbnb's delayed job scheduling system, Camunda, AWS Step Functions, Conductor, Eventbrite Scheduler, and of course, Temporal. After doing a sweep of all of the platforms, two of these choices stood out to us. One was, of course, Temporal, as it pretty much checked all the boxes in our checklist. And second was Dine-In, a platform that we wanted to learn a little bit more about. The main reason for our curiosity was the author of the platform, Airbnb, and how they seemingly used it for scheduling delayed jobs. We were eager to understand Airbnb's use cases with Dine-In and Temporal, as we learned they were also huge Temporal users, a little bit more, considering the similarities that we have on our platforms. While we host cars, they host homes. As you can imagine, the life cycle of both of our bookings is fairly similar. You can search, find, and schedule a booking, and each of the bookings has a start, middle, and an end date. Now, if there was only some way that we could learn about how Airbnb was using Dine-In and Temporal, and what their recommendation would be, well, lucky for us, there was. The Temporal team graciously connected us with engineers from Airbnb. They shared their engineering journey with us, which was surprisingly similar to ours. They had started out with Quartz as well, moved on to Dine-In, and then had started to adopt Temporal for various use cases. The bookings team recommended that we consider Temporal for a recommendation lifecycle, and even recommended Temporal Cloud to avoid some of the challenges that they had faced with in-house management. We weren't sure if they were getting some form of a kickback from our sales rep, Alex. I'm just kidding, of course. But whatever had happened had worked. Whatever happened had worked phenomenally. We were sold, and the conversation helped cement Temporal as an ideal choice for us. After deciding Temporal as an ideal platform, we wanted to plan and develop an MVP that would help us prove the power of Temporal to our leadership and the rest of the engineering team. As we were planning the MVP, the first thing that we had to decide was whether we wanted to self-host or use Temporal Cloud. A big part of our evaluation criteria was availability of a fully managed solution. We had self-hosted Quartz in the past and had faced significant issues doing so. On top of that, the reliability and availability issues that we were currently facing accelerated our need to move off of Quartz. So the solution we were looking for needed to be fast to adopt and easy to manage. Temporal Cloud was a clear choice. After making the decision, we were tasked with how we can translate some of these Quartz jobs into workflows. Our scheduling system currently supports two kinds of jobs, cron and individually scheduled, or dynamic jobs. The cron jobs are jobs which are, as we all know, run on a cadence that run either by the minute, by the hour, or daily, can sometimes run for a few minutes or other times for a few hours. Have functionality where overlapping runs are oftentimes discarded. Due to reliability issues, some of our cron jobs also often acted as watchdog jobs for other processes or individual jobs, which either failed to run or were just picking up the slack from those jobs. While dynamic jobs are a little different from cron jobs and oftentimes were tied directly to a reservation event. These were scheduled hours, months, days, or even weeks in advance. Changes to a trip resulted oftentimes in a new scheduled job at a different state. And these were the jobs that supported veto logic, which pretty much means that if a job with an incorrect state was fired, it was automatically discarded. A first pass through of about 120 Quartz jobs that existed in our system which were both, of type individual and cron, revealed about 20 jobs which were directly related to a trip and reservation lifecycle. There was no consensus of definition within these 20 jobs. Some of them were dynamic, the other were cron. A lot of them were hard to understand and read what was going on. We scoured through about 20 of these jobs and found a list of logically connected events from them. For the first time, we were seeing a reservation workflow definition. A clearer picture emerged. Unfortunately, so did overlaps. We had originally thought of having a single workflow for a reservation lifecycle, but we quickly realized that events within a single reservation might conflict. Consider the example above, in which we have a workflow with 5 actions, where S represents the start time of the reservation, and E represents the end time of the reservation. The third action takes place 12 hours after the start time, and the fourth action takes place 24 hours before the end time. For long-running reservations, this works. But the moment the length of the reservation shortens, we see overlaps. In the second example, you can see that there is some level of ambiguity in the workflow definition around where the third and the fourth actions should be placed within the workflow definition. The ambiguity would violate the deterministic nature of the workflow definition. This led us to the concept of anchors. An anchor became an event that a specific workflow that actions within a specific workflow would revolve around. Each anchor we found in the reservation lifecycle would result in a new workflow. An example of this would be the start trip time anchor. You can see that the add driver job, the download app reminder job, the start trip job, and the start feedback job all seem to revolve around the start trip time, which would become the anchor. A similar pattern can be observed in the second example here, the booked end. Anchors provide simpler and more purposeful workflows. Once we had identified the need for anchors, we came back to the question of what the simplest workflows would be for us to prove out temporal. We zeroed in on 2 of the most critical jobs that had a history of challenges. Start trip, the action that actually starts the trip, and trip extension reminder, the action which sends out a notification to a guest to potentially extend their trip a few hours before their trip is supposed to end. Choosing these 2 jobs or actions, both based on different anchors, told us that we had to create 2 different workflows, a booked start workflow and a booked end workflow. An important consideration for any workflow is ensuring idempotent operations. Idempotency, as many of you probably already know, refers to the property of executing an operation multiple times with the same data produces the same result. An example of this is pressing the unlock button on your car key multiple times. Unless your car is really fancy, doing so would not really do much, except the first time. Similarly, starting a trip or sending a notification twice or more shouldn't really do anything. This required us to verify that the job execution code for the actions we chose was idempotent or not. Because of how many times Quartz had failed and restarted for us in the past, most of the job execution we were dealing with had already idempotency baked in. After evaluating idempotent actions, we moved to the question of where reservation workflows and the respective workers would live. We had initially evaluated placing these workers and workflows within our monolith. However, that conflicted with our team's overall goal of monolith decomposition. Additionally, it was counter to our long-term vision of teams being able to maintain their own workers and their own workflow services down the line. We were also concerned with adding bloat to an already bloated service, which would significantly slow down developer time, deployment time, and lead to a hindered developer experience. We had also anticipated that doing so would produce some challenges with worker sharings, and we did not want to open the gate for the possibility of teams sharing critical workers. These reasons led to us creating a separate reservation workflow microservice that would house the temporal workflows as opposed to integrating temporal within our monolith. Once we had figured out where our reservation workflows would live, it was time to put it all together in the form of a design. This is the design that we came up with to enable Turo's first reservation workflows. We started with we created a workflow microservice, a reservation workflow microservice, that would house all of the reservation-related workflows and workers. Our temporal activities within the workflows will call our monolith, where we created a single RPC endpoint that takes the reservation ID and a job name. This endpoint would execute the job execution code under the hood when called. Our monolith also produced reservation booked, edited, and canceled events to a queue. These events were consumed by our microservice to create, edit, and delete reservation workflows. With the architecture set, it was time to set a very important goal for ourselves. With the importance of jobs that we were migrating in mind, we decided that a reasonable goal would be to not break anything. My manager agreed with this goal. His manager and the CTO agreed as well. We believe the CEO shared this goal with our CEO, who appreciated a desire not to break anything. With the goal to not break anything in mind, we decided to take a multi-phase approach where phase one would be to just log an action when it takes place, as opposed to execute the actual call within an activity. Phase two would involve making the actual monolith RPC call. This would allow us to know that temporal was triggering actions when expected and compare Quartz and temporal parity. With the planning done, it was implementation time. As a part of not breaking things, we needed a way to test things locally. It seems that directly testing in production is frowned upon and also dangerous. We leveraged Temporal's Docker container and also the Temporal CLI to do some local testing. The setup was super easy and developers were able to ramp up very quickly, +1 to Temporal's developer experience. While the strategy was still not to break anything, we realized that moving from phase one, which simply logged, to phase two, which executed the job, risked potentially breaking things. To mitigate the risk, we decided to use feature flags within our RPC endpoint. Through this, we could control the execution of requests to the RPC. This would allow us to run Quartz and Temporal at the same time while providing with fine-grained control over temporal job executions. This would also allow us to accurately compare and account for both of the executions. With a feature flag in place, we were ready to start ramping up the executions for our first workflow. Over the course of the day, we slowly ramped up from logging to executing. Our goal to not break things worked. Nothing broke. We monitored everything: our temporal workers, the CPU usage of our monolith, and also of our temporal microservice, database operations for both temporal activities and Quartz executions, if the job actually did what it was supposed to do at the time that it was supposed to do at. Most importantly, we saw that the idempotent checks on Quartz skyrocketed, meaning according to data, temporal was significantly outpacing Quartz. Over the next few days, we continued to monitor and noticed a slight increase in our workflow execution latency and a drop in our sync match ratio on our temporal dashboards, indicating that a task backlog was forming. This was a result of long-running workflows that would have majority of their executions at the 30-minute mark. We met with temporal solution architects Keith, thank you Keith, and Tiho, thank you Tiho, and we're advised to increase the number of workers, the pollers, the task slots, and our cache size within our workflow workers. These adjustments significantly reduced the task backlog and gave us a good idea of how to manage our temporal workers and where we should place alerts in our monitoring dashboards. This is evident in these charts that can be seen on this slide. Right after we made those changes, our replay latency and our workflow task execution latency significantly dropped. With the ramp up done, it was time to analyze our results. We really like this chart. That's why I'm sharing it with you guys again. Temporal was winning. We really like Temporal. Things continue to not break. With the Temporal MVP successful, everyone at Turo was very excited for Temporal. Teams began to inquire about how they could use Temporal and also not break things. We were ready for this. From the start, we had planned to support these requests better and make it even easier to adopt Temporal. Every step along the way, we had been building runbooks and documentation for our implementation, which was very helpful to all the teams. We had also prioritizing working on an internal Turo Temporal library, which to fuel ease of adoption. Additionally, we began to evangelize the power of Temporal in our various guild meetings. Everybody immediately was on board. One of the teams that had reached out to us was one of our host team that had recently used Quartz to develop a new feature. This popular feature, called scheduled messages, allowed hosts to create their own messages, such as welcome, thank you, etc., which were to be sent to guests at their own picked cadence. The Quartz job processing these messages was failing and always falling behind. Messages scheduled for a certain time would be often delayed by several minutes, leading to a detrimental user experience for both of our guests and hosts. It took us 1 day to lift this job from Quartz onto Temporal. The results, as you can see, were rewarding. Temporal completely eliminated message delays. We went from thousands of messages being delayed to none. Problem solved. With more and more teams reaching out, we began to focus on creating an internal Turo temporal library. We had a goal of creating an internal library to simplify adoption by providing Turo-specific support for things such as temporal cloud connectivity, simplified worker and activity creation, and simplified scheduled workflow creation. In addition to an improved service creation process, this allowed us to launch temporal-ready microservices in less than a week. After celebrating our MVP and not breaking anything, and resolving issues with scheduled messages, and following another significant Quartz incident, Turo decided to go all in on Temporal. We have now committed to fully retiring Quartz by the end of the year. Wouldn't it be ironic if the week that we're all here prevents us from meeting that goal? It won't. With the completion of MVP and the success that Temporal was enjoying at Turo, it was time to look towards our post-MVP goal, Quartz retirement. With the focus of retiring Quartz by the end of the year, we paused development on a reservation workflow microservice and took a step back to holistically analyze 120 Quartz jobs that we had in play. We bucketed each one of these jobs by domain, identified potential events and anchors, and chased down owners to understand the intent of each of these jobs. The result was a catalog of more than 100 jobs. It was a big catalog and would take us a long time to convert into workflows. During this time, we would still have Quartz running in the background with its myriad of reliability and availability issues. The solution for Quartz retirement became clear. Lift and shift it is. While the potential for improvement through new workflows was there, our primary goal is to retire Quartz by the end of the year. Our new catalog, however, allows us to better plan for the next phase, where we workflowize everything. Iterative impact for the win. With the lift and shift strategy in mind, we began exploring what the right way to do so would be. Temporal's new scheduled workflows were the clear choice. We decided to create a scheduled workflow microservice which would house all of these scheduled workflows. However, we soon realized that as a part of lift and shift, we would have to do the same thing over and over and over again. Close to 100 times if my count is correct. The entire plan sounds mind-numbing. Nobody wants to do the same thing over and over again. In comes the decision to create a config-based migration approach. One advantage of facing a horribly monotonous task is that it forces you to be creative. We realized that for each job we chose to migrate, the only difference amongst them would be the RPC action names, the cadence, and the timeout. Everything else could be exactly the same. For each job, we can create a new temporal schedule, which would spawn the same workflow under the hood, depending on the cadence. This workflow will then call our monolith back using the same activity definition with just different parameters. Additionally, we decided to place the non-reservation jobs in domain-specific packages, so that it would be easier to identify the domain when we finally start to workflowize everything. The decision to use a config-based approach to lift and shift would simplify each job migration. After we completely retired Quartz, we anticipate Temporal to play a big role here at Turo. There are a number of engineering initiatives currently underway which either would benefit from Temporal or would allow us to pursue Temporal adoption faster. Our eventual goal is to evaluate all of the scheduled workflows with their respective domain owners and build up more reliable and scalable systems similar to the reservation workflow microservice. We expect the majority of our cron jobs to be baked into workflows very, very soon. Additionally, we have several teams adopting Temporal and moving towards workflows instead of creating cron jobs for critical functionality. Some examples of this are our payments team, which chose to use workflows to develop their new split payments feature, and our toll teams, which chose workflows over cron to add improvements to the toll functionality. This would help This will help everyone, including developers and our hosts and guests, as everyone likes to definitely get paid on time. We will continue to work on improving our library and find better ways to design and deploy workflows. Another goal is to provide product with clear documentation around workflows without source of truth issues. In other words, our code should tell the story and could be visualized for non-technical users at our company. We would love to have an open API equivalent for temporal workflow definitions. This is something that we are planning on pursuing. Or maybe some of you have already developed this. If so, let's chat after. Before we go on to the key takeaways, I would like to take a step back and take some time to thank and acknowledge a few people. This was clearly a team effort, and none of this would have been possible without them. I would like to thank members of our leadership here at Turo, Avinash and Moj, the API services team, Adam, Alice, Andre, Josh, Minglun, Russell, Shruti, Siri, many of whom are here today. The members of our greater Turo platform team, who are Victor, Johan, Adam, Doug, Brian, and Harrison. I would also like to thank members of the Temporal team, Maxim and Samar, the founders of Temporal. Alex and Kevin are amazing Temporal representatives. And of course, Keith, Tiho, and Taylor are amazing Temporal solutions architects. Now, no presentation is complete without us talking about key takeaways. What have we learned through this entire process? Well, number one, planning is important. It seems obvious, but we cannot overstate the importance of taking a pause and planning for the future during certain steps. Doing so while evaluating the entire Quartz landscape allowed us to figure out a clear and achievable goal that would help us achieve our short-term goals while also preparing us for the long term. Having a focused goal will get you, number two is having a focused goal will get you over the finish line. Once we decided that retiring Quartz by the end of the year was our goal, we've stayed focused on this. It's a question we ask before every decision. Will this get us to Quartz retirement by the end of the year? If the answer is yes, please continue. If no, reread the goal. Number three, pursue incremental changes. Incremental changes for the win. Our platform is not ready for a complete adoption of workflows at the moment. We focused on making a ton of improvements before we workflowize everything. Introducing workflows to our platform right now would be akin to blowing out a candle on a birthday cake with a wind tunnel. We need to make sure that our cake is ready. Incremental changes allow us to improve our platform's reliability currently, while also preparing for workflowization in the future. And, of course, cannot overstate this enough, but community. Don't be shy about engaging with the greater engineering community. More often than not, you will find engineers willing to collaborate. The Temporal community is vibrant and passionate. Nothing can prove this more than our collaboration with Airbnb. I thank you guys for your time and hope you guys enjoyed the presentation.